Good morning and a very warm welcome to all present here. This wonderful lockdown morning, Gartex Texprocess presents to you a webinar on water-free, chemical-free dyeing, which is introducing the green revolution. Gartex Texprocess in India is a well-known trade show which will be held from the 21st to the 23rd of August this year at Pragati Maidan. While the whole world is fighting this crisis, they're also talking about change, and that change is being sustainable for future generations. This friction between the environmental scarcity and societal benefits is increasing every day. This makes more and more companies to become from linear to circular model. Today we have with us Kasper Nossent. He works for Textile Systems as the Managing Director for Asia and based out of Vietnam. Dyco is the world's first supplier of commercial and industrial carbon dioxide dyeing process for polyester that is 100% water and chemical free. Wow, we want to know, Kasper, we'd like to know more from you. And what is this green revolution all about? Over to you, Kasper.
Thank you, Priyanka, for the introduction, and good morning to everybody. It's a little bit unusual time to do this webinar, but I look forward to share my insights on sustainability and also what we can offer as Dyco to help the industry to become more sustainable. I'm based in Vietnam. Also, we are in a sort of voluntary lockdown. Businesses are still open, but I do work from home occasionally and go to the office here. And I hope for all of us that soon we will be able to meet in person again. But before that, I would like to share our insights on the industry and also on sustainability. The slides will be shared with you via email, and my email address is listed on the first slide. So if you want to reach out to me, please drop me an email. As we all know, we live in a world with an ever-growing demand for more and more garments, more and more fabrics, more and more textiles, more and more fiber. We work in an industry, and these numbers are all pre-corona, so probably the numbers might flatten off a little bit for this year and next year, but let's assume that most of these trends hold up. We have to feed and clothe a growing world population. If we look at the predictions for 2030, we look at about 8.5 billion people. That also means that these people need to eat, they need to be clothed, and that will increase the demand for more and more fabrics, and in the end, more and more garments and apparels. So on the graph on the right side, you see the global fiber production demand. You will see that there is a strong growth in especially polyester fibers, because that is where the market will grow the fastest over the coming years. All the other fiber types, they will remain constant or slowly growing, like cotton. Cotton will always be remaining a dominant player in the market, but the growth in the global demand for fabrics and textiles will come from polyester. The expected growth of 4 to 5% a year for the market alone means that by 2030, we look at over a $1.3 trillion global textile market. That includes the production of fabrics, yarns, everything related, and most of these fabrics end up in the apparel industry, but also in the automotive industry, upholstery, which are fast-growing markets as well. But that leaves us with a dilemma, and the dilemma is: do we aim for unlimited growth, or do we aim for sustainable growth? And there is no clear answer to what is right and what is wrong. If we don't grow our economies, we can't feed our people. But if we grow our economies the way we do today, we will not be able to feed them anyway, because we will cause a lot of havoc on the environment. We will lead ourselves into a lot of trouble. So we need to find a middle way that we can actually have sustainable growth and keep sustainability in mind, because in the end, we only have one world, and we cannot get another one to actually try again what we are doing today. So this leaves us with the dilemma of choices that we need to make in applying resources to either economic growth, and what kind of resources do we want to apply to this. One of the most scarce resources over the coming years globally will be water. And if we look at our industry, we currently, on an annual basis, use about close to 80 billion cubic meters of water. If you put it into perspective, it's about 4% of the global freshwater usage. It's only for one industry. It's quite worrying in a way. We use about 20,000 different chemicals to process and produce fibers, fabrics, and dyeing and finishing of these fabrics, and also to make apparel and garments. It is estimated that 20% of the global industrial wastewater production is contributed to the actual textile industry. So that means that we do have a significant footprint on the world. And this is something that we need to take into account when we want to grow our economy. I've spoken on several interesting events in India over the last year. And a lot of these seminars and conferences were about how India can grow. And India has to grow, of course. The industry will grow, but it has to come at a sensible trade-off where you can actually turn sustainability into an opportunity rather than a sort of burden that you have to commit to because people want you to commit with it. You can grow an industry, especially in the polyester world, where you can position yourself in a unique way, where you can become sustainable and use it as a unique trademark over the other competing countries that you currently look at. So when we look at the market and all these growth predictions that we have, if we look at the predictions for the global clean water availability, fresh water availability, in 1995, the usual places on the earth that are relatively dry had already issues in actually finding enough fresh water to use for the industry, but also for the population and for the agricultural industry. In 2025, with the growth of the current economy and the growth of the world population, you see that this area where we actually start competing for freshwater resources is becoming bigger. And one of the interesting areas that we have to look at is Southeast Asia and Asia in general, because the majority of our textile supply chain is actually based in this part of the world. So that means that when the industry is starting to grow the way it currently does, and the demands go up, this means that the biggest burden of freshwater depletion will actually happen in Asia, because this is where our value chains are located. So we need to change. We need to do something that can actually help us to grow this industry without destroying our valuable resources for our future generations to come, and even for the generations today. Just to give you an indication of, okay, when we talk about polyester in this case, when you look at the impact of wet processing on the polyester product, this is actually derived from a life cycle analysis done in Sweden on a series of products for the Swedish market. And one of the things that you see is that the actual impact of, let's say, the product, in this case a polyester dress, is actually quite large when it comes to wet treatments. This is in pre-treatment, post-treatment, the dyeing part of the fabric. And if you look at the total impact of the whole Swedish garment industry, so that's the demand for garment consumption, clothing consumption in Sweden, you see that the predominant impact is on wet treatment. So this is only for one country. Imagine that every country in the world looks at a more or less similar profile in their products. You see that wet treatments are having a significant impact on the sustainability of the industry. So something has to change. And when Dyco started off 10 years ago, we say we can't solve problems if we keep using the same way that, if we use the same way to create them as that we used to. So basically what we try to do is we try to do something radically different. And instead of focusing on using less water, using less chemicals, still having those in your product, still having those in your processes, we actually said we don't want to use them at all. We're going to do something radically different. What if we can dye fabrics without using a single drop of water, not having any processed chemicals added to the mix, and not having any wastewater generated during the dyeing step. When we started up 10 years ago to develop this technology, we faced a big burden on our R&D because this was all novel. Nobody had done this before. And we managed in the last 10 years to actually develop this into an industrial proven process where we can actually dye fabrics without water, without chemicals, and without generating wastewater. So what is the environmental impact when we look at this just from a very, very holistic perspective? One of our machines running in the industry, only one machine with an average output of about 3 tons a day, already saves over 33 million liters of water. We save about 170 tons of chemicals, and we use significant less energy, not only in production, but also in post-treatment. And what do we mean with post-treatment? Well, if you don't generate wastewater, you don't need to treat wastewater. And with the current legislations, if you look, for example, at India or other places in Asia where the laws become very restrictive, and you have to focus on zero liquid discharge, 100% recycling, that means that you need to introduce all sorts of very energy intensive wastewater treatment systems, such as reverse osmosis, brine concentrators, to actually fully recycle your water. This will significantly increase the energy footprint of your mill to a point where you can use 2 to 3 times as much energy per kilo of fabric as you would do without using any of that. So when we look at CO2, because that's in the end the answer to what we think is a big problem. The use of CO2 is actually quite interesting. Carbon dioxide is widely used in the industry. It has very good characteristics of being a cooling agent. It can be a cleaning agent. And it is a byproduct of most industrial processes. So it is widely available in the world. You can capture it from all sorts of generation points, power plants, industrial processes. And the good thing about carbon dioxide is that it is the same quality everywhere in the world. If we talk about CO2, we always talk about the same CO2. So whether you source that in India or you source that in Vietnam, it is always the same. That means that in the process, you have a lot less variables to actually worry about. This is a safe process gas. It is non-toxic, non-flammable. That also means that it's very safe to handle. And that makes it very usable in the industry. One of the other very good characteristics that we have at carbon dioxide is the moment that we make it supercritical. That's the actual state of matter that we use in our process. We can actually dissolve dispersed dyes right into the CO2. When we do that, we don't need dispersing agents, because in regular water dyeing, you do need a lot of additional auxiliary chemicals to actually keep your dyes in dispersion. You need wetting agents, you need anti-foaming agents, you need pH stabilizers, hardness modifiers. There's a lot of things you need to add to your dye bath to actually get a consistent result. In our case, the dyes will dissolve naturally in the carbon dioxide. No need for additional chemicals. So we only use pure dyes. So what do we bring to the mix? Well, of course, no water, no process chemicals. Most importantly, we don't generate wastewater. And on top of that, significantly less energy compared to traditional water dyeing, and especially if you combine that with very advanced wastewater treatment systems. It's a relatively quick process. In our case, during the dyeing step, we apply the color, but we don't need to do any post-treatments to actually keep the color in the fabric. So there is no reduction clear step needed after dyeing. After dyeing, the color is fully fixed to the fabric. We have an extreme high batch-to-batch consistency, matching 100% for the same color and the same fabric. Why is that? Because of the consistency of CO2. It's always the same anywhere in the world. The fact that we use pure dyes, and the fact that our complete process is monitored in every step. So we have a very, very consistent dye process, meaning that we have a very high repeatability, and that gives you a very high batch-to-batch consistency. We use significantly less dyes in CO2 dyeing compared to regular water dye. On average, we use less than 1% weight on weight in dyeing, which is about a factor 2 to 3 less than traditional water dyeing. So how does it work? Well, basically, like I said, the ingredients we have is CO2, pure dye stuff, pure powder dye stuff, and fabric. We combine that together in our machines, where we actually create an environment of 250 bar, and that is needed to make our CO2 go supercritical. In that state, we can actually dissolve the dyes, and then at that stage, we can also use CO2 as a solvent or swelling agent for polyester itself, so we can deliver the dyes very deep into the core of the fiber. After dyeing, we end up with dry fabric when it leaves the machine, and the color is fully developed. And then the fabric is ready to go into post-processing, wet post-processing or dry post-processing, regarding on the process streams and product streams that you intend to do. In a nutshell, our process is based on 3 distinctive elements in our machine. We have a tube, which is the whole process is based on beam dyeing. We have a tube where we actually insert a beam with fabric. We have a storage vessel with liquid CO2. We pump that into the vessel, increase the pressure to 250 bar, raise the temperature to about 120 degrees centigrade. That can be plus or minus a few degrees if you want to. After dyeing, when we successfully leveled out the color over the whole fabric, inside out, beginning to the end of the beam, we recycle up to 95% of the CO2. And that CO2 flows back into the main storage vessel and can be used again for the next dye batch. The remaining 5% we lose due to energy inefficiency, but that part is not recycled. And clean CO2 is later on used in the next dye batch. So what makes it unique? Well, besides the obvious I already stated, we also have a machine, as you can see in this picture, where we can dye both knit and woven fabrics in the same machine, but we can also dye yarn in the same machine. So you have one tool that is applicable for both fabrics, polyester, and yarn polyester, which is a unique concept in the world that at this moment is not available to the market. The machines in itself, they're designed to be industrial robust. We are currently at the 4th generation of our technology. We started in 2010 with the first prototype, generation 1, and we're now at generation 4. And the machines are designed to run into, let's say, large-scale polyester production facilities. Average output is about 24 dye batches a day, divided over 3 vessels, so 8 per vessel. Loads up to 200 kilos of fabric with an average width of about 150 and 150 grams per square meter density or weight. Based on fabric dimensions, you can even increase the capacity over 200 kilos per batch, but we see that for a lot of apparel applications, about 160 kilo, 180 kilos per batch is a quite common load factor. We don't have a minimum load. You can load up to 10 kilos of fabric if you want to, and there's no minimum load to the machine. Maximum fabric width is about 2 meters. And like I said, it's 100% water and chemical free. So after dyeing, no reduction clearing needed, straight to post-processing. So one of the things with sustainable technologies is that you need to prove 2 things. First of all, you need to prove that it is sustainable. And that is very easy to prove for most technologies, not only CO2 dyeing, but others as well. Everybody believes that the sustainability impact is enormous. No water, no chemicals. Everybody falls for that. You don't need to convince people in that area. Where you do need to convince people is that it makes commercial sense. Because in the end, sustainability goes as far as the moment where a transaction needs to take place and people are starting to monetize the technology. If running costs are significantly higher than traditional processing, people are less inclined to use it. Companies don't work as a charity and they have to make money at the end of the day. So one of the things that we have tried to prove together with our first users in Taiwan and Thailand, and now also our customers in Vietnam, is actually showcase industrial usage and use cases and business cases where you can actually prove that sustainable processing does have a business case that makes sense, and that you can make money out of running a factory which is purely based on sustainable offerings rather than using a mix of water or using a mix of sustainable technologies. And the example that we created together with a customer in Vietnam is to have the first factory in the world that only uses CO2 dyeing to dye their fabrics. And this gives a unique proposition and also a unique showcase. People can actually see that the production is 100% centered around CO2 dyeing, but the customers of this specific customer, called Clean Dye in Vietnam, also are global brands and retailers. They buy into this. They believe that sustainable processing, whether that is CO2 dyeing or any other technology, is the future. They have to comply to this. They have to start using it. And for us to actually have this factory and have this business case available to show to the industry is a massive plus for us to promote sustainable technologies into the market. Like I said, there is no such thing as charity, and there's no such thing as doing things because for the sake of doing it sustainable. It has to make commercial sense. And together with our customers, we always try to prove that there is a business case in the market, whether that is on a cost level, whether that is on product basis toward brands and retailers globally, or the combination of the two. There has to be a business case attached. And that is what we have worked through over the last years, is to build these showcases. So at this moment, we run machines in 6 different customer sites all over Asia. All of them have a commercial intent of using the machines for a variety of their products. Our first customer was the Ye Group in Thailand. They're early adapters with a lot of new technologies, and they already started using the first generation prototype back in 2010. Quickly after that, we moved into Taiwan to work with some of the leading mills there, like Far Eastern and Formosa and Eklat, and actually start using CO2. But all of these companies always used hybrid factories. So part of their production was in water, part of their production is in CO2. Until last year, when we had Clean Dye coming into the market with 3 Dyco machines, having a factory of 10 tons production a day, 10 to 12 tons a day, only CO2 dyeing. And at the moment, we are working closely with Indian companies in Bangladesh, and Korea to actually, and also Vietnam, to actually expand the installed base of CO2 dyeing into new customers as well, because we believe that there is an opportunity for sustainability and that you can monetize sustainability. At one point, we have to avoid as an industry that sustainability becomes a commodity where people think that it is just a standard specification of a product. It is actually the only specification that will matter in the future. And there is a business to be built around it, because without sustainability, there won't be an industry. There won't be an industry either if there is no uptake and no demand. What we see in the current market is that not only governments are starting to push on legislation and sustainability, but we also see that from societal organizations like Greenpeace that start to push on making things better and trying to avoid the use of chemicals, the use of water, the use of energy, or less the use of energy. And that is something that is important, because that is societal pressure. Consumers become aware of the fact that they need to change their behavior in order to actually become more sustainable, to make the value chain more sustainable. But the most important factor in this are actually the brands and the retailers. They form the middle man between the market and the technology, which is mostly installed in textile mills. If the brands don't generate value out of sustainability, and if the brands don't bring that value back to the value chain where people can start investing, we won't have an industry that will invest in sustainability. So at this moment, Dyco, together with our customers, we work very closely with a few or large group of brands and retailers in the public domain and non-public domain to actually build business cases around sustainability with good success. If you look at large companies like Nike, Adidas, Gap, PVH, Decathlon, they are all very active and actually working with our customers to start sourcing specifically CO2 dyed materials. And their demand for more and more sustainability in their textile processing is becoming bigger and bigger. Not only for CO2 dyeing, but for all sorts of combinations of sustainable technologies. And this is where we believe the market will go. The brands have to take a lead, governments have to take a lead. The consumer has to be aware that at one point it is not sustainable that you can go into a shop and buy a $10 pair of jeans, because that means that the whole value chain needs to make money out of that $10. But it also means that if you want to change that value chain, that at one point the denim maker or the people that make the cotton t-shirt or whatever it is needs to invest in new technology. But if you on a brand side do not allow that specific mill to recoup that investment to actually contribute to the sustainability agenda of that brand, we do face a problem, because how can you implement sustainability into the value chain if you cannot recoup that investment over a time span of years? And that is why we are very interested in working with brands that actually recognize this, that actually see value in sustainability and actually help the people that invest in sustainable technologies to actually recoup those monies over years in a collaboration and partnership with brands and retailers. So at this moment, if you look at the global impact just for CO2 dyeing, the numbers look impressive. If you look at 40 million yards or you look at over 10 millions of kilos, they look impressive, but if you really look into the detail, they only a drip in the ocean. If you look at the sourcing volume for Adidas, only for polyester products, that exceeds hundreds of millions of yards per year. So with the current installed capacity, we not even be able to supply the full demand for Adidas and their polyester products. So that shows two things. One is that we're at the early stage of adoption into the market, but it also shows something else. There's a huge potential. Because we got overflown with requests from mills, from brands and retailers to look for capacity for CO2 dyeing. And we only have a limited set of customers at the moment. The implementation rate is relatively slow and long. So everybody that starts to invest in the technology or invest in sustainable production processes will have a market opportunity. Because in the end, if you look at the sustainability agendas of brands and retailers, 2025 is coming in very quickly. And a lot of these roadmaps run to 2024, 25. So if you need to change as a brand and you need to become more sustainable in your sourcing, you need to start converting your value chain. And these conversions can take up to 12 to 24 months before technology is in and fully utilized for the production capacity of that specific brand. So we can't wait too long. The industry, to keep up with the agendas that people made over the years on the brand side, the retailer side, we need to invest billions of US dollars into the market to actually fulfill the needs of the agendas out there in the market. So there's a huge opportunity for all sorts of sustainable technologies. Last but not least, in our case, we will not be existing if we didn't work with partners when it comes to dye stuff. One of the key elements in our success for this technology is that we can't do this by ourselves. We're only a machine builder, but this also illustrates that none of the new technologies that come to the market, whether that is printing technology, dope dyeing, all of them rely on a circle of partners. Nobody is good to provide the whole solution, and same for our solution. We are working with Gartex in India, well known to most of you. We've been working with them for the last 15 years, I think by now. And they are our longest lasting partner in this whole journey. And they have developed a full set of dyes for polyester. We are working with them on other dye ranges as well for different synthetic materials. And Gartex is also the largest CO2 dye supplier in the world. And they supply to all our customers all over Asia, to research partners all over the world. And also with dye stone enhancement and Achroma, we have a good relationship to develop specialty dyes for new applications in the automotive, in all sorts of specialty fiber applications. And we do believe that over the years, this technology will grow with a wider range of applications into more materials than only polyester. But we do believe that every journey starts with the first step. We have taken one. And it's a little bit unfortunate that the coronavirus did hit the world, because we have been working very closely with a few leading mills in India. And if you look in the public domain, you will find that we have been working for a couple of years with Arvind, but also with Raymond. And actually getting close to bringing this technology into the Indian market, or at least have Indian mills investing in it. That is currently all a little bit delayed, all these processes also for Bangladesh. But we do believe that in the second half of this year, we will be able to expand further into the Asian market, and maybe globally over the coming years. Last but not least, thank you very much for your attention. And the picture you see here looks similar to the one that you saw of the clean dye factory in Vietnam. And I would like to invite people that are seriously interested in the technology to, and when time allows us to do it, to come and visit us in Vietnam, to have a show, to have a tour in the factory there. Because what you see on this picture is actually how the dye house looks. It starts to look like a clean room. There's no water, it's dry, it's extremely clean, and this is how we want factories to look in the future. Thank you very much for your attention, and looking forward to your questions. Thank you.
Thank you so much, Kasper. I think I would like to take the most common question that's asked here is, can this technology be developed for cotton, leather, denim, or blended fabric?
Yeah, that's a question I was expecting when talking in India. The answer is twofold. One is cotton dyeing has for a long time and still is on the radar of Dyco. However, Dyco is only the technology provider. We only make the machines. We don't do the chemistry. We know that in the market, not only in India, but also in Bangladesh and in Vietnam and in all sorts of places in the world, there's a big interest in cotton dyeing with CO2. And there's a lot of research being done on it. At the moment, it is chemically impossible to dye cotton with CO2. Unless somebody cracks the chemistry, that reactive chemistry for cotton fibers works in the CO2 environment, we will not see that very soon. Our expectation is that this will be a long-run project, which has been picked up by several parties in the market, and we just monitor it. But I don't expect any commercial applications soon in the coming years to hit the market. That's one. The other thing is that from a strategic point of view, Dyco has a very strict focus on synthetic fibers. The reason for that is two. One is sustainability. So focusing on synthetic fibers, we already focus on more sustainable fibers than cotton when it comes to environmental impact. So our focus is on polyester, which is easy to do in CO2. The next one will be nylon, and a few specialty fibers, all in the synthetic region. The other part of the answer...
And Kasper, what about rayon and viscose?
It's the same as for cotton. It's all based on reactive chemistry that doesn't work in CO2 at the moment. However, and that is the answer that does apply for the Indian market, we can dye polyester cotton blends, not only on yarn level, but also on fabric level. However, we cannot dye the cotton, so you create a melange effect. But the CO2 doesn't affect the feel of the cotton at all. So it leaves the fiber unstained, and it gives the same natural feel to the cotton, the same soft feel as in water dyeing, but you create a melange effect. And we've done trials for several customers and mills in India to do melange on yarn and on fabric level. And there is a big interest, especially for suiting materials and shirt materials. So there is an opportunity, but in the blended fabrics, yes. And then the other part that we look at is fiber dyeing. And fiber dyeing will provide an entry point into India as well for blended fibers with cotton, for example.
Casper, how is it more sustainable than a dope dyeing process in polyester?
I think if you look at colorization of yarns, then of course dope dye is by far the most sustainable colorization method for polyester, because you take away the whole need for dyeing, right? You apply it in the melt, and then you extrude the fiber with the color. However, there are limitations to that. Solution dye or dope dye uses pigments. Pigments are particulated dye stuff particles. So in very fine denier yarns, you will find that high loads of pigments will actually affect the characteristics of the fiber. So specific fiber types and lower deniers you cannot make in solution dye. The other thing is that we do see that in the market, consistency in keeping the color in dope dye is very difficult, because you need to work with large batches. Color matching is very difficult, and costs are relatively high. We don't see CO2 dyeing and dope dyeing as competing technologies. We see them as complementary technologies, because parts of the products that we can do in CO2 dyeing, you cannot do in dope dye. And some products, for example, black in extrusion dye, is extremely cheap, and probably way cheaper than doing it in CO2 in large volumes. So we see it as a complementary technology, and we have been working and still work with quite some large polyester suppliers to actually look at using a combination of dope dye and CO2 dye, where we can actually combine the two technologies together.
Thank you, Casper. The next one, what is the functional parameters like fastness parameters to sublimation?
So all the dyes that have been introduced into the market by Colotex and by other dye stuff suppliers, all have been tested thoroughly on one thing is solubility in CO2, and the other thing is fastness properties. When we came to the market, one of the investors in Dyco is Nike. And Nike was one of the first users together with Adidas. So all dyes that came to the market had to comply with their high standards for color fastness. So all the dyes that have been developed over the past years all fit into the box that meet the standard requirements for high-end brands like Nike and Adidas.
How can they prepare batch? What's the pre-treatment required for this?
So for CO2 dyeing, we use a beam dye process. So basically what we require our customers to do is to have a good dye result, is to make sure you scour your fabric. So for knit fabrics, use a proper scour. For woven fabrics, use proper desizing. Make sure that there is no oil content left in the fabric, or a very small fraction of oil. After scouring or desizing, we need the fabrics to be heat set prior to dyeing, so before dyeing. Then you wind the fabrics onto the beams using standard beam winding equipment for beam dyeing in water. And then you dye the fabrics. And after dyeing, you follow the normal post-processing routes for wet finishes or any other lamination or printing steps. So we don't divert from the existing process routes in factories. The only thing is that we require a heat set before dyeing and don't need one after dyeing.
Casper, I'm going to combine 3 questions here for you. What is the economic viability, the payback period, and the per day production of this dyeing process?
Okay, let's start with the production. So on average, depending on fabric types, on average, the machines produce per day about 3 tons of fabric per day. That's the output generally. For yarn, it will be a little bit higher because we can load more kilos in the tubes. But for fabric dyeing, it's around 3 tons per day. When it comes to unback and cost viability, like I stated before, there is no business case if there is no commercial incentive. So here I need to make a statement that we are, in most cases, cost competitive, but we're not cost competitive for every polyester dye application. in my presentation, you've seen that there is a very strong link between sustainable technologies, and in this case, CO2 dyeing, and global brands and retailers, because they are pushed to become more sustainable and have a very high price point for their products because of all their stringent requirements for the value chain. So for the global polyester sports apparel market, upholstery market, yes, we can be very cost competitive. If you look at the local markets, whether that is in Vietnam, in India, Bangladesh, the local polyester markets, for example, take the Surat region, we are not cost competitive. That's unfortunate because there we do see that the impact of the technology can be enormous, but our capital investment is just too high. We talk about $3 million for one machine. And with the average output on a daily basis, we do put ourselves in the sweet spot for a lot of global brands for the export market, but for the local polyester markets in some regions, we are, just from a capex point of view, too expensive, and then the running costs become too high for most of these mills to afford it. We do believe that there is an opportunity there for shared facilities, but that's a different discussion. But when we talk about sustainable investments, we look at investment periods with earnbacks of approximately 5 to 10 years, depending on the business case. We do have business cases with significantly better earnback times because of the circumstance of the business case. But in general, when we talk to big mills to make investments, we look at investing in the future. We don't look at short-term gains with this technology, because you do invest to have a textile mill in 20 years from now and not to make money tomorrow.
What about the fastness, the level of fastness in fabric by this method?
So the level of fastness needs to meet the standards of the let's say the global market for brands and retailers. So we do need to meet the fastness property standards of Adidas, Nike, Columbia Sportswear, North Face, all these guys that have very high standards on fastness we need to meet. Another thing that we need to meet is that we need to be able to dye evenly. So levelness and color consistency are very important as well, which are more process related. Fastness properties are dye related. But yes, we do need to meet these standards. And on average, the dyes of Colortex and all the other dyes, they score 4 to 5 on all fastness properties that you can measure.
We have an attendee called Manish Gupta. He wants to know about the machinery project energy consumption. How much area will it take? That is the total area required to install this.
So let's start with the installation in square meters. So the machines need to be installed on a reinforced floor, because our machines are heavy. So they weigh empty about 130 tons. So the floors need to have a weight bearing capacity of 2.5 tons per square meter, which is quite normal for most process environments, process factories. The square meters required is about 130 square meters, maybe 140. The width of the machines is approximately 10 meters and the length is about 13.5.
Can you briefly explain some other emerging technologies that are replacing chemicals in textile processing, like enzymes and probiotics?
Well, specifically for enzymes, that is very cotton related, for desizing. That is something that we don't look at. We do look at combinations of processing technologies for synthetic fibers. So earlier you asked about dope dyeing. Well, we do see a combination of dope dye and CO2 dye to be very, very interesting. Because we can do things they can't do in dope dye, and there are things in dope dye that we can't do in CO2. And the combination of the two would actually provide a very sustainable solution. We also closely look at, for example, low liquor ratio or dry finishing technologies, like spray finish. Because that would significantly reduce the water footprint for any post-processing. And we look at combinations where you can use printing technologies and CO2 dyeing in post-treatments as well. So yeah, we do look at several, but for us the leading ones is low liquor ratio post-finishing, low liquor ratio pre-treatment of polyester or synthetic fibers, or no liquor at all, and combinations of dope dye with CO2 dye.
How can they get the lab recipe and replicate in bulk? One question. And the second one is, Prashant would like to know that the test results of dyed fabric on color, fastness criteria, that is water dyeing and carbon dioxide dyeing.
Okay. Yeah, let's start with the last question because it's the repetitive one that we answered before. So they meet the same, they even or better, the fastness properties and the test results on fabrics compared in water and CO2. One very important note is that CO2 doesn't affect the yarn. So in our case, when you dye the yarns, because we don't use any post-processing with chemicals, we don't affect the properties of the yarn. So that's an important one. And when it comes to testing fastness properties, our scores are even or better than the existing water test results. What was the other question?
The lab recipe and replicate in bulk.
Oh, yeah, that's a very good one. Because when we came to the market, we did realize that making lab recipes is extremely important. Making color recipes is you can't do that in water if you after that dye in CO2. So what we have designed when we came to the market is actually a very small tube, metal tube that we can use to make lab dips in CO2. And that gives you the actually recipe that you need to develop for the color. And from that, you can scale up to the big machine. However, in water dyeing, there is a minimum load for machines. In our case, there's no minimum load. So your first dye run can be with 10 kilos of fabric to establish the right process conditions to obtain the color. And after that, you can dye the bulk in a consistent way.
Okay, so the next question is, Geeta wants to know, isn't carbon CO2 a chemical? How can it be water-free and chemical-free webinar when it is, and call it as a green revolution?
Very good question. This links to the circularity discussion. So carbon dioxide in itself as a gas is a natural gas. It on a daily basis, we breathe it in, we breathe it out. It is part of the air that we breathe in and breathe out. However, CO2 is also produced in production processes. So whether that is power generation, whether those are petrochemical processes or any production process on the earth produces CO2. And that CO2 can be reused. You can either work it up into different chemicals if you want to, but you can also capture it and actually capture the exhaust gases, then purify them, liquefy them, and then use them as process gas. And that is what we do. So we don't produce CO2 for our machines. We actually capture, or not we, but our gas suppliers and gas vendors, they actually capture the CO2 from chemical processes or power generation and liquefy it and purify it and then resell it as a process gas. Process gases for CO2, the applications are not only for us as a solvent, but you can also use it as a cooling agent, as a cleaning agent. Is very widely used as a cleaning agent in the semiconductor industry. So yeah, the applications are wide. Is it a chemical? In our opinion, it's not. We actually give it a second life, so we tap into the circularity. But when it comes to the dye process, we only use the gas as the carrier. We recycle the gas up to 95% and reuse that, but we don't use any additional chemicals. You could argue whether dyes are chemicals. Sure, they have a chemical composition, but we don't add any additional process chemicals. No auxiliary chemicals, no additives, no wetting agents, no dispersing agents, nothing like that. So in the true sense, yes, it is chemical free because we only use pure dyes and CO2 as the carrier. And that makes it, in our opinion, a chemical free process. But it is an interesting discussion on whether you call CO2 a chemical or whether you call dyes a chemical. But if you look at the pure sense, no, we don't use chemicals and we don't generate any chemicals either.
Thank you, Kasper. Another one, what is the energy consumption of the machine?
So the energy consumption it's a good question, because we do get a lot of questions about this, because if people look at our machines, they say, wow, that must be very energy intensive. Having liquefied CO2, having supercritical CO2, heating, cooling, that must be enormous in energy usage. If we look at the energy usage in kilowatt hour per kilogram textile, we use more or less the same amount of energy for our whole machine, which includes the cooling, heating of CO2, the recovery of CO2, the recycling of CO2, and the dye process. So on average, it ranges between 1.6 to 2 kilowatt hour per kilogram of textiles. That excludes the energy usage for wastewater. So if you want to make an apple-to-apple comparison, you need to include for water dyeing also the energy usage to treat your wastewater. And then you will find that regular water dyeing, by definition, always uses more energy than CO2 dyeing. And that factor can vary from 2 to 3 depending on the different water treatment technologies that you use.
Varun Grover wants to know, and he says, I'm dyeing 10 lakh meters, that is 300 tons every month. What would be the setup cost, these machines for a dyeing unit for these capacities, and how many washes this fabric can handle?
Okay, the answer is, without digging too much in detail, the factory that I've shown in Vietnam, Clean Dye, which is using 3 Dyco machines, and it includes the whole setup that includes the pre-treatment and post-treatment as well. That whole factory has an average output of about 10 to 12 tons per day for knit and woven fabrics. The capital investment for 1 Dyco machine is approximately $3 million US. So for an average output of about 10 tons a day, you do need approximately $9 million US to set up the factory, only with our machines. Additional investments in stentor frames, if you already have them, you don't need them. Winding equipment, pre-treatment, post-treatment equipment, all sorts of auxiliary stuff that you need to do to the building. The factory in Vietnam is about 10 million to 11 million euros, including all the other machinery they have as well. But for our machines, for 10 tons a day, it's about $9 million US.
This brings us to our last question. Do you need to wash machine after every batch?
Well, that depends on how you dye. So, and I like to make the analogy with a regular water dye house. What you try to do is you try to group different shades together in a dye tube. So one machine has 3 individual dye tubes. So you can dye 3 individual colors in parallel, 3 different fabrics in parallel. So if you want to change to the next color, you try to select a vessel that is close to the color that you want to dye. And we have customers that can do that with very minimal cleaning effort. If you look at the Clean Dye factory with 3 machines and 9 dye tubes, they hardly find any effort in cleaning in between batches and in between colors, because they can pick a color that actually matches a color that was previously dyed. But on average, if you run 1 machine, which is in most cases not very productive and efficient, then cleaning can become an effort, because you do need to clean between different colors, and that can take up the same amount of time as that you have in regular water dyeing. That can take up 4 to 6 hours, depending on what kind of colors that you want to change. But in regular dyeing, if you dye the same color or colors in the same color family, cleaning efforts are minimal to 0.
This is the last question, and I would really like to know your concluding remarks on the sustainable dyeing and the impact of COVID. What will happen after COVID gets over?
Sorry, the last part of your question was?
I said the impact of COVID. What do you see, and how are we going ahead post-COVID?
Well, I don't have a glass ball or crystal ball, so it's very difficult. If I had the answer, then A lot of people would thank me for that.
I'm sure.
But I think if we look at the market and all the projects that we currently have, COVID will generate a big shockwave in the industry. That's for sure. There's no denying about that. If I look at my customer base, which are predominantly tier 2, so dyeing mills, they are pretty much sheltered at the moment. They do see a decline or cancellation of orders for the current running season. But they do see a significantly drop in the forecast for next season, which will start in the summer this year and runs till the end of the year. So yeah, they do see underutilization of their capacity. However, the biggest shockwave is of course on the garment side, where the direct impact is from day one when COVID hit. Orders have been cancelled because retail shops are closed. And I do foresee that the latent effect of that impact of shop closures, and nobody knows how long it will last, this will have an effect on the investment agendas for companies because they're in survival mode. So I think that effect will last for another year on the market. But there is also an opportunity on this side, and that is on the fact that dye houses are capital intensive. I'm based in Vietnam. There's a lot of new dye houses here. They will not move. They're not easy to close down, and they're not easy to scale down. They have to run production, but they also look at, okay, what can I do to actually come better out of the market? People will go bankrupt. Companies will go down. Can I invest in future technology to actually make myself better? And there's a small group of people that have the fortune to do that because they have the capital laying around to do it, because they're not so much driven by cash flow. So I do think that we do have some opportunities still left in investments for sustainability on the mill side. Unfortunately, I do think that the biggest shakedown at the moment will take place on the garment makers, which is very cash flow driven, very human intensive. So yeah, that will have a massive impact, unfortunately.
Thank you so much, Kasper. Thank you for joining in today. And we wish you good health, and
thank you.
Hope all of us get back soon to our normal lives.
Yeah, thank you very much for the opportunity. As a last remark, I did notice on my phone that I have a barrage of questions coming in through LinkedIn and probably also my email, which is currently switched off. So thank you very much for everybody that joined in, for the interest. I appreciate that very much. Please drop me an email to reach out for more questions. When the time allows, I try to make my way back to India. I travel most of the time, like a couple of times a year. And this year, unfortunately, I hope that I can be back when things get better and actually face the customers again and speak at conferences and be closer to the market. Because I do believe that India in itself has a huge opportunity in the textile market to present itself as a global player. We work with a couple of big mills in India. One of them is Arvind. We have a few others as well that are actively looking into using polyester as the stepping stone into the global export market, linking into sports apparel, activewear. And I do think that for a lot of Indian companies, there is a huge opportunity there. And if you can do that in a sustainable way, you can actually carve out a niche that is currently nowhere in the world available on such a large scale. So yeah, that was that's the positive note, I think, to it.
Thank you. We're running out of time. I think most of the questions can be taken offline. We will share a few with you, which you can directly reply back. And looking forward to see you in India very soon at the next Gartex show.
Thank you.
Thank you.
Thank you for the opportunity. Bye-bye. Okay, thank you so much for the organization of it.
Thank you. Bye-bye.
Thank you. Bye-bye.